Welcome to this tutorial on pod security standards. In Kubernetes, securing your workloads is critical to maintaining a safe and reliable cluster. Pod security standards provide a built-in framework to enforce security policies on your pods. Throughout this video, you'll learn about the 3 security profiles and how to implement them in your Kubernetes environment. Pod security standards, or PSS, define 3 security profiles that control how pods behave and enforce security best practices. This framework was introduced to replace the deprecated pod security policies. Pod security standards is a built-in Kubernetes security framework that is enforced at the namespace level using labels. This means you can apply different security policies to different namespaces based on your requirements. Pod security standards define 3 distinct security profiles. First, the privileged profile provides unrestricted access with minimal constraints. Second, the baseline profile offers balanced security by preventing common misconfigurations. And third, the restricted profile is highly secure and follows hardening best practices. Each profile serves different use cases, from system components requiring full access to production applications needing maximum security. The privileged profile is the most permissive policy with no restrictions whatsoever. It's ideal for trusted workloads that require elevated permissions. This profile allows all capabilities and host access without any security constraints. It's typically used for system components and infrastructure pods, such as monitoring agents or network plugins. However, it's not recommended for application workloads because it allows for known privilege escalations. The baseline profile is a minimally restrictive policy that prevents known privilege escalations. It blocks the use of host network, host PID, and host IPC settings. This profile also restricts privileged containers and limits Linux capabilities. Additionally, it prevents host path volume mounts, which could otherwise expose sensitive host files. The baseline profile is the default choice for most application workloads because it balances security with ease of adoption. The restricted profile is the most restrictive policy, following pod hardening best practices. It enforces running containers as a non-root user, which greatly reduces the risk of privilege escalation. This profile drops all Linux capabilities except net-bind_service. It also requires seccomp profiles and restricts volume types to only safe options. The restricted profile is recommended for security-sensitive applications where maximum protection is required. Pod security standards can be applied using 3 enforcement modes. The enforce mode rejects pods that violate the policy, preventing them from being created. The audit mode logs violations to audit logs but still allows the pods to run, which is useful for monitoring compliance. The warn mode shows warnings to users during pod creation, but permits the pod anyway, helping teams identify potential issues without blocking deployments. You can use these modes individually or combine them to gradually implement security policies. Let's look at how to implement pod security standards using namespace labels. You apply these standards by adding specific labels to your namespace definition. The label pod-security.kubernetes.io/enforce sets the enforcement mode to restricted. Similarly, you can set audit and warn labels to restricted as well. This YAML configuration ensures that all pods created in the production namespace must comply with the restricted security profile, providing maximum security for your critical workloads.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.